Hello and welcome. Welcome to PCAP's Native Prairie Speaker Series. My name is Caitlin Monroe-Seiler, and I am the Stewardship Coordinator with Saskatchewan Prairie Conservation Action Plan, or PCAP. Today, Xulin from the University of Saskatchewan will be speaking about woody encroachment in Saskatchewan. And this is a topic that the PCAP Steering Committee wanted to hear about, and it's been really popular with over 300 people registered so far. Before we begin, I'd like to state that we respectfully acknowledge that we are on the traditional territories of many Indigenous nations and communities, past and present. For millennia, they have worked to protect these landscapes and the life these areas sustain. I'd like to thank these original caretakers and acknowledge the ongoing work and presence of Indigenous peoples in Canada today. And just a few items before we get going, I'd like to note that PCAP's Native Prairie Speaker Series is a monthly presentation about anything to do with native prairie conservation or species at risk. I'd like to invite you to join us for a presentation about snowy owls on February 15th by Scott Wadensall from Project Snowstorm, and it's going to be great. Also, don't miss our March Native Prairie Speaker Series webinar about highly pathogenic avian influenza in wild birds by Xulin City of Environment and Climate Change Canada, and you can register for these webinars and other webinars through the PCAP website. Lastly, our annual Prairie's Got the Goods Week will be taking place March 6th to 10th, and feel free to join us for a week-long series of webinars about ecological goods and services, and we'll be posting our schedule on our website shortly. A reminder to our listeners out there, if you have any questions during the presentation, please feel free to type it into the questions section of the webinar dashboard anytime during the presentation. And if you're on a cell phone app, you can send it by chat to the organizer, and questions will be answered towards the end of the webinar. I'd like to take a moment to note that financial support for today's webinar is provided by our presenting sponsors, Canadian Forage and Grasslands Association, Saskatchewan Cattlemen's Association, and Wildlife Habitat Canada, and in-kind support has been provided by the University of Saskatchewan. So without further ado, a little bit about today's presenter. Dr. Xulin is a professor at the Department of Geography and Planning, and she is a Bachelor's of Science in Forest Management and a Master's of Science in Forest Economics from Beijing Forest University, and a PhD in Remote Sensing and Biogeography from the University of Kansas. Her research focuses on remote sensing of grasslands since her PhD program in the tall grass prairie and moved to the mixed grass prairie in 2001. Her passion is for native prairie conservation. For decades, her studies have used remote sensing tools to determine solitary measures of grassland growth and productivity, such as cover, biomass, leaf area index, canopy height, and structural heterogeneity. In addition, she has investigated the effects of climate variation, burn and grazing in grassland ecosystems, as well as species at risk habitat assessment. A barrier to continued progress in assessing ecosystem health and its services is to integrate different elements and approaches holistically. Therefore, she aims to contribute to achieving optimal and high-quality ecosystem services while maintaining sustainable grassland ecosystems. So with that, I will pass it over to Dr. Wah.
Can you see my screen?
Yes, perfect.
Okay, thank you, Kathleen. And this is a great opportunity. I appreciate the opportunity to be able to share the research among our group. Before I start my talk, I would acknowledge my two PhD students. Eleni, and she's a PhD from 3 years ago, and Yihan just started his PhD last year. And many of the presentation slides are from them. The research part is mainly from Irini, and a few literature review part from Yihan. So my talk is about woody encroachment in Saskatchewan. Let me see. Okay, why do we care about the woody plant encroachment? Is this a problem to our province? If we see this study by Li et al. Published last year, this is research. Okay, let me move this. Conducted in southwestern United States. This is a Chihuahua Desert, the 2 long-term ecological research sets. This is quite a famous study in the area. Chihuahua Desert is a long-term study. The 2 sets are Janada and Sevalata. So they try to see how the grassland ecosystem processes. In this study, we can see this study about resource spatial heterogeneity. They discover investigate the potential degradation. They consider the wind and water erosion and the fire activity there. If we see the transition initiated with the grassland, after some shrub encroachment, you can see the landscape changed. Even though the spatial heterogeneity is sounds like increasing, yes, but with wind and water erosion, with less fire frequency, the potential degradation is increasing. And at the beginning, the situation can be reversible as long as you keep the fire management practices. However, as the degradation of the woody encroachment continued, the ecosystem of the landscape changed. Finally, it can change to a state with shrubby dune land, so with limited or no grass there at all. So in this stage, it will be very difficult to move back let the ecosystem itself to grassland ecosystem. So this is a study by them, and this is in the southwestern United States. Will this problem occur to our province? So do we care about the situation? We didn't care that much for a long time, but now it seems it is getting more severe. We absolutely don't want our grassland change to shrubby dune land for sure. And then Elenia mentioned that she's a PhD student. Her research was appeared on the Plain and the Valley. And then Mr. Blaine had to send a letter to her. And in the letter, we see he stated he's a farmer, farmed in southeast Saskatchewan for nearly 50 years. So he has a first-hand experience about our grassland, about our landscape. He said, when my grandfather came over 100 years ago, there was not a tree that would stop a plow. This piece of land today, 40 acres, is 70% covered in trees and brush. So clearly we can see this is a problem. In the past, we talk about the grassland mainly focus on quantitative change. I have a project working together with Environment Saskatchewan, Agriculture Saskatchewan, and funded by ECCC. That's a 2-year project. It's a project called the Prairie Landscape Inventory Plus, because this project was continuous with a project by them. I wasn't involved. I just involved in this stage. The purpose is to map the prairie area, try to understand how much native prairie still exists, and try to pilot the area, the changes. That's normally we see the quantitative change, the area change converted from one land cover to the another land cover type. But the shrub normally occur is in the still counted as grassland, but encroached or sneakily get into grassland. In that situation, it's more qualitatively issue. So if we don't pay attention at the beginning, the problem can be getting severe. Okay, in my talk, I try to cover a few aspects, some concept or terms used for shrub encroachment, and what the impact this shrub encroachment for grassland at different scales, and what are the driving factors based on literature. Main concern is the driving factors, and then if we know exact driving factors, we can recommend the management practice to be able to prevent the situation in early stage. And then I talk about our approach, because I'm in the remote sensing field. Our approach is mainly focused on remote sensing approaches. And then we talk some results we come up. You can see we started this research not long ago, only the recent two years. So our result is still at the early stage, still lots of going on there. This is my passion or my future and current main research. I talk about my research. And then the terms used for woody plant encroachment appeared in different literatures and in different aspects, different locations. The main term used is about woody plant encroachment, also called woody encroachment. Sometimes include like a brush, shrub, or woody plant. So you can see in the definition, the main thing is about no matter it's a woody plant or shrub or even trees, it's talking about can be native, the shrub, the woody plant in native, as native species or as non-native species. It can be existing shrub getting to higher coverage or higher in density or introduced to a new landscape. It can be talking about area expansion or the intensity changes. If area changes, that may related to land cover changes. Intensity is quantitatively. The change, like we see, if it's the shrub invaded to a different landscape, and sometimes it will change to the last stage, cannot change back anymore. So it always starts with the early encroachment and the intense effect and to the last stage. And the other terms can be used in literature. This is a paper published by Xulin in the journal last year. So other terms can include like invasion for shrub or woody species. It can be talking about the thickening. It can be talking about the regrowth and so on. So for these terms, sometimes focus on rainfall as the clear influence for the shrub infilling the grassland. And sometimes it can be for specific area like Africa. For shrub, we know it's a long-term ecological processing. So when we talk about the shrub, we must understand it is in stages. We can define, people define it either 5 stages or 4 stages. So in that situation, we need to make sure to understand the transition or the how that initiated. Normally, the start is always with a shrub seed, and the seed can be dispersal. That change to the seedling. When the change to seedling start to grow to mature, and then the process even accelerated. So at the early stage, when I was in Kansas, I know to prevent, that's for tall grass prairie, to prevent the shrub encroachment, there's a very effective approach, that's burning. And there's latitude, longitudinal line that's based on the precipitation. You can see that from shrub to grassland is based on the precipitation division. And then the shrub can be easily to encroach to the tall grass prairie. The very effective approach is to burn every year to make sure the seeds can be burned. So if we can control the shrub encroachment at the early stage, that's better. The sooner the better. And the impact, when we talk about the impact of the shrub encroachment, we can see the impact can be at different levels. It can be at the small scale level or in the broader scale or ecosystem level. So with this study, Master published in 2016, we can see the diagram from the top. Shrub study to encroach the individual plant, and this is studied to increase. And then you can see this study, the x-axis shows the shrub encroachment, and the y-axis showing the ecosystem services. They studied for 4 aspects. One is the soil fertility, hydrology, carbon sequestration, biodiversity, and the grazing value. If we see evaluate, we can see soil fertility and hydrology is a kind of increase as the shrub encroachment starting, and then reach to a level. The variation is diverse, quite different. The carbon sequestration is increasing dramatically until reach a certain level. And biodiversity, we see biodiversity at a certain level is increasing, only reach to a certain level and started to decrease. However, for the grazing value, if our pasture or grassland, the function or the services for economic purpose, because the grazing value at the beginning is look like increase, but very soon it dropped dramatically. So this is at a small scale. If we see at a broader scale, lots of studies try to, maybe this include some small scale as well, and also include the broader scale. We can see this is a quite frequently cited paper. It was published in 2014. We can see the diagram on the left is the arrow drop down is a woody plant encroachment, and the right side the arrow is brush management, is to try to control or remove the shrub. We see each function or each service is talking about different aspects: the forage production, the water quality, or the wildfire, the carbon, the primary productivity, quality, biodiversity, and many aspects, recreation value. And we see on the edge, see either plus sign or minus sign or question mark. If it's a plus, then indicate an increase. If it's a minus, it's a decrease, or mixed result. And also the question mark indicates not enough information for that. If we examine clearly, we can see the if the shrub started to increase the landscape, the forage production is down, is a pure minus sign. But this is for sheep and cattle. But if we're talking about for goat, actually it's increase. You can see the grazer type played a role in that. And also, if we see productivity, primary productivity, that's a mixed result. Can be increased, can be decreased. If we talk about above ground carbon, it seems it's all indicate the productive above ground carbon is increased. No question for that. So another thing is talking about the pest or pathogen, it is increase. And we can see majority of them actually in the mixed result. So that's the at a broader scale for different parameters study related to woody plant encroachment. And as one example, you can see let's study talking about the above ground biomass. Clearly, we can see the biomass is higher, much higher for shrub in wooded landscape compared to the pure grassland. And the annual net prairie production is almost 3 times higher than the grassland. If we talk about the impact at the ecosystem scale level, at the ecosystem scale, we see we're talking about the information for habitat. I need to find my note. for this is the ecosystem. Okay, sorry, I didn't move it. For habitat, for ecosystem services, environment aspect, food industry, and economy aspect, many aspects. We know for grassland in the global level, nearly half of grassland degraded. And for the northern mixed grassland, the most degraded globally, that's the area concerned the most. And also in Canadian prairie, how much native grassland still exists. This is no solid result yet. Some say 30%, some say 20%. Based on our project, it seems probably lower than that. We don't have the final product yet about this. If we see many organizations worldwide started to concern about this woody shrub encroachment issue. And then you see, based on the Deng's paper in 2021, this is a woody plant encroachment set globally. You can see it with a different landform, different ecosystem, many sets. That means it's not a local issue, it's a global issue. Okay, so what's the increase? How much? What is the increase rate for woody plant encroachment? This is not a consistent result, but from this paper, also Deng's paper, we can see this process changed, increased the majority of the area, probably in around 0.1 to 1.1. However, some research indicate 1.1 to 2.5-ish. So this is occurring globally. And also the change based on their study, they studied from 2002 to 2018. From 2002 to 2010, the study was dramatically increased. The encroachment rate is much higher. However, after 2010, the rate dropped slightly. So this is globally in the much broader scale. How about in North America? The woody plant encroachment in different ecosystem, we can see majority of them probably in the range from 0.3 to 0.4. And in the central Great Plains, that's the place with the highest woody plant encroachment based on Barger's paper. That was in 2011. And you can see southern Great Plains is nearly 1%, but the central Great Plains is much higher, above 1.5. So that indicates we're in the central Great Plain, in the northern part. What is our shrub increasement rate? We don't have a clear understanding yet. So that's why we need to know what's going on there. And then to map the shrub encroachment area, first we need to see what are the drivers, what are the factors to influence. We know for woody plant encroachment, this phenomena, the factors can come from different aspects, can come from environmental aspect, the management aspect, and the community, species community aspect. If it's for environment, it can be climate, temperature, precipitation, CO2 level, and topography, and the soil, and the wind, and so on. So the reason we for Saskatchewan, we didn't have that problem that much. Probably our precipitation level is low. I know the reason for Kansas because the precipitation level is high. That's why in the boundary area, the shrub try to invade it into the grassland as long as enough precipitation there. But for us, we have a dry. Our annual precipitation is quite low. But with the global climate change, this phenomena will be different. That's why we started to concern woody plant encroachment. Our farmers, ranchers realize this issue as well. And from management, we know grazing. For grazing, they're confused or the controversial result about the grazing because it affected many grazers. It's cattle, bison, sheep, goat, related to the grazing interval, grazing intensity, and all different aspects. Fire normally is quite to get a solid conclusion. Fire can prevent woody species to get into grassland and other land cover types. For the species, it relates how quick the seed can establish in the area, what community, and the transition from the small seedling to adult mature trees, and also the carrying capacity related. So many factors actually influence the woody plant encroachment process. I mentioned that the grazing is the most controversial result. You can see some studies indicate grazing is an effective approach. Using grazing can make can remove the shrub, or they can graze the shrub to the certain lower level. And some others say no, grazing can actually promote the shrub encroachment. And some others say, no, actually there's no impact that much at all, because it is highly associated with the landscape's initial condition. So this is a study by in southeastern Arizona. They have the 70 years of study without a fire, so they can test the grazing effect on the landscape. And that indicates 74 years of landscape based on the grazing. You can see compare grazed and ungrazed. It's a study initiated in 1932. You can see from different biophysical perspective, cover, density of biomass and the structure. And so you see if it's indicate no difference, or that's NS, or greater or lesser or equal or not equal. So their conclusion actually say what's in the paper indicated protection from livestock since 1932 not only failed to deter woody plant proliferation, but actually promoted it relative to grazed area. So we can see this is their statement. And from their study, from some study, we can see general conclusion can be grazing resulting in grass cover because of the cost gaps in grassland cover. So that can cause benefit the woody plant establishment. And the grazing contribute to Fire's role in woody plant encroachment is reducing the fuel load. And also livestock often consume and transport variable shrub seeds. So we can see that's a reason grazing can cause different results. So sometimes we suggest more different studies, specific set locations, and the remote sensing can be a tool to investigate the long-term historical changes. So this is another about the grazing. Grazing is the one because for our Saskatchewan, we probably will use grazing as one controlling factor to control the shrub encroachment. That's why we can see different studies from other areas, other locations, how the grazing affected the landscape. This is the study talking about compare the different two grazing treatment, continuous and rotational grazing. And they have the two replicates, replicate A and replicate B. So if we see the plant, the PLAND called the percentage of landscape at a 4 level of grass cover, high, medium, low, and bare soil. On the very left, the darker bar is the bare soil. We see the study initiated in 2010, and the grazing, continuous grazing studied, the replicate A studied in 2009, and the rotational grazing studied in 2011. We can see from the first 2010 to 2013 to 2015 or 2017, we see the plant, if we see different component, low and medium and high and bare soil. One thing we can see about the bare soil, it seems the bare soil percentage increased slowly, and to 2017, it reached to a certain level. No matter it's a continuous grazing or it's a rotational. For rotational grazing, the increase even much higher. And then we can see the change from low intensity to low cover to high cover, medium cover. If we see 2013, majority is in the low cover category, and 2015, the majority is in the high medium cover category, and to 2017, it is going back to the low cover. So I think probably this is also related to climate variation, not only for the grazing factor. And then we see in their study, they try to use remote sensing, NDVI as the cross sign on the top. We can see NDVI for the landscape can confirm kind of the situation. You can see overall the NDVI value is the lowest, is much lower in 2013. So they use the remote study to use remote sensing there. And then another study in Yellowstone National Park area. That's probably most closer to our province, closer. So they have the bison grazing. The title is Migrating Bison Engineer, the Green Wave. So this work, if you read their paper, there is something like a storytelling to tell about the interesting how the bison try to get to the shrub area. So is that really the bison can reduce the shrub or not? We don't have a solid conclusion, but based on their study, you can see they have some hypotheses based on their tested their hypothesis. The hypothesis is called the green wave hypothesis. It indicates the hypothesis assumes green wave is controlled by variation in climate, weather, and topography, and its progressional dictates the timing, pace, and extent of migrations. So they focus on how the herbivores behavior on the forage changes, and their certain conclusion they have is it's like grazers, like engineers to change the grassland ecosystem. And it is not clear how the green wave determines their movement. However, in the Yellowstone basins, their migratory movement to the wave of spring green up indicated where the spring green up, that's the basin will go into. So they have some conclusions. They say grazing effects on broader scale patterns of the green wave. First, the basin created massive grazing lawns, which are larger than most fenced basin preserves in North America as they migrate across the extensive Yellowstone grassland. And also when basin grazing was more intense, vegetation green up earlier, more intensely, and for a longer duration, as measured. This is based on NDVI. The line indicate the figure is quite difficult to read. You can see the line, the area indicate low grazing intensity, high grazing intensity, how the NDVI changes. And the more intense grazing also elevated the net above ground production. So I had some research about the grazing effective for grassland as an ecosystem. At that time, we didn't consider the woody plant encroachment, but our conclusion is the intermediate. It's not our conclusion. We just confirm the theory. Intermediate grazing can generate the highest biomass production. So productive is higher at the intermediate grazing intensity. So what are the approaches we can study this woody plant encroachment? We know remote sensing is getting popular tool for ecosystem studies, because remote sensing, even with the satellite, available satellite image, it's over how many years? So started in 1972, over 50 years. So we see, I just use the figure to see so many satellites in the space. The spatial resolution can be varied from under meter to kilometer level. And the temporal resolution, the revisit time, can be daily and to monthly or whatever. So many images available as archives, and so many more images will be available. We will get more higher spatial resolution, higher spectral resolution, and higher temporal resolution. And we know when we talk about remote sensing, we not only talk about the satellite, we see remote sensing at different levels: ground level, close range, or the UAV. UAV is very popular now, the airplane and the satellite. To understand how remote sensing work in monitoring ecosystem, we see majority of the remote sensing using the solar radiation, but also we have some others active remote sensing. The sensor can generate the energy to the ground, and the satellite will receive the energy or the information from ground. That's why if we have the shrub into this area, the spectral signature or the information received by the satellite will be different. You can see the ground level spectral response curve, different vegetation, different ground, the curve will be different. And this is the example how remote sensing can be very effectively influence the landscape, and remote sensing can capture the difference. This is an image acquired over Grassland National Park area. Grassland National Park is in the southern part of Saskatchewan. I think most people know that. That's a beautiful landscape. It's one of my favorite area, because I studied my research at the Grassland National Park. That was in 2003. We visited the park nearly every year. However, the pandemic stopped us to collect more data there. I'm hoping I will return that soon, since the pandemic is over. So the park officially established in 1988, I think. So at that time, if you see the satellite image, this is from the Landsat, and this is a standard false color composite image. The red color indicates higher vegetation. We can put the west block as the actual holding area. This is probably outdated the boundary layer. So we see outside of the park and inside the park, no difference. The landscape is just smoothly transit from within the park and outside the park. And 2006, when we get another image for the area, we can see without the layer of the park boundary, we can see the park area clearly marked on the satellite image. So it look like there's a straight line there, and outside and the inside is different. Very different. The inside the park is much darker compared to the outside. We know Grassland National Park reintroduced the basin in 2006, and then for the first few years, the basin only moved in the northern portion of the park. And I need to move faster. So we can see after maybe on the image of 2008, you can see the difference between from outside to the park disappeared, because the basin was moving there. And then the southern part, you can still see clear the boundary. But till 2013, that difference throughout the park disappeared, because the basin moved, wander around in the entire park area. And then Kelly mentioned about my research. This my interest to shrub encroachment actually initiated with Mr. America Vignis, and he was the director of Saskatchewan Basin Association at that time. And he noticed, he has his own pastures. He associated with many people. It seems there's some observations. Basin can actually help prevent the shrub encroachment. So I was interested, and we were hoping to do some research, and he provided me with some locations, and we said we need funding to do the work. So we applied the ADF, but luckily we didn't get the funding. So I said, okay, I can renew my NSERC in this topic. So that's how last year I renewed my NSERC is focused on shrub encroachment issue, because very limited research in Saskatchewan. We see many research in other locations, but limited research in Saskatchewan. And we don't know the current distribution. We don't know the drivers. We don't know what's the best management practice to control this issue. So we know grassland provided service in different aspects, right? Food and climate regulation and educational purpose and many aspects. But woody plant encroachment can greatly affect this service. And I need to move fast. So my student Eleni did a review about this from the literature, and that review paper published the Canadian Journal of Remote Science. We really appreciate the reviewers. We don't know who they are, but they helped us greatly. So we found this is worldly. Some information is still missing for this research. If you're interested, you can read the paper. So for the last 3 years, we started to collect the data at different locations. One is in the Kernan Prairie Research Station, owned by university and managed by a Plant Science department. And also we did a 1 year data collection together with Dr. Erica Lam for the Bristol Rangeland area. And also based on a project we received from government, Saskatchewan government, we did some work at the Cypress Hill Interprovincial Park. And the Grassland National Park, we didn't do any collect data for this specific topic yet, but I'm hoping we can do that, especially with the basin grazing there. Okay. Some pictures, when we conduct field work, we collect the biophysical, spectral, leaf area index, and the different aspects. And then one result to demonstrate how we did evaluate the result, we can see for cover, we collect data in different seasons, and we also collect the biomass data in the summer, maximum growth season. One thing we can see is the shrub cover appeared higher in spring because the grass is still senescent at that time. So the cover seems lower in other seasons. Okay, and we also collect the ground level spectral data. Ground level spectral data, we try to see what's the minimum shrub cover we can detect using remote sensing, also for the 3 seasons and different level, under 10%, 10 to 35%, to see what is significant. This is published in Journal of Sensors. And also to see different shrub cover, different quadrant, because we measured each quadrant and compare to the landscape, the changes as well. We also want to see, because satellite image with a different band or different wavelength location, we use a hyperspectral to detect which is the wavelength location better to detect the shrubland. You can see the green area is a significant difference to be able to detect. Okay, another project I mentioned is for the Cypress Hill Interprovincial Park. And so the purpose is using very high spatial resolution air photos, it's not a satellite image, to see where the shrub located, and the 3 shrub types there. And then the result, we can see, visually you can see where the shrub located. One major factor is the road. So, and other factors in the paper also indicate that it's just recently published in Jakarta International. So many factors, topographical factors or other factors, we can see this is not directly talking about the driving factor. It's showing what kind of landscape situation the shrub appeared higher coverage. Okay, I mentioned we did some work. One is for the separate skill project. It's funded by Ministry of Parks, Culture, Sport, and that's for the project is a small location, but we collected the data for 2 years. And the project completed, but we are still working on research. Right now, Xulin is working on driving factor analysis to see the changes over certain time period. And another project we also worked for government is talking about the management grassland management plan for Douglas Danielson Professional Park. This project finished, we are also still working on the research. And my NCERC I mentioned renewed last year and for 5 years. Another project is Dr. Eric Lamb's project, the Matix project. It received the funding last year, but student Elise, she started her master program this January, and we will also hire more undergrad students and so on. So that's a 2-year project. Okay, for my future research, and this is my passion. I really want to know some answer. I want to help with the ecosystem protection or the healthy sustain the ecosystem health. And I want to see what's the distribution, how much change occurred in Saskatchewan, and find a way to be able to detect shrubland encroachment, woody plant encroachment using remote sensing with the advanced remote sensing technology. We are hoping to find the driving factors. And also another thing is what is the grazing effect really? Compare bison and cattle and different aspects. And the whole purpose is ecosystem health assessment currently not really consider the shrub component. It considers some way, but not in the way included into the model. Okay, to end my talk, I want to use the statement from Blaine again in that letter. And he stated, brush can encroach or recede depending upon how the livestock is managed. All plants attempt to move into new areas. The various stressors that natural systems, drought, soil type, pH values, salinity, animal impact, put upon these plants ultimately determine the landscape that we observe. So that's why we see we need to investigate these factors. Okay, that's my talk. And thank you for listening. And I look for suggestions and look for collaborations because this is a new research area for me as well. So any collaboration, we can work together, provide the field location and provide the suggestions. I'll be appreciated for anything. Thank you.
Thank you very much. That was a really awesome presentation. And as I mentioned at the beginning, it was really on demand and we had a lot of people here. And I think I speak for everyone that this was great. Thank you. And you mentioned in your bio that you're really passionate about prairie conservation. That was definitely obvious. So thank you so much for sharing that with us. To all of our attendees, if you have any questions, feel free to type it into the question section of the webinar dashboard. And Dr. Wah, we do have one comment here, I guess, from a listener named May. May says, in Manitoba, when we developed our rangeland health assessment method, we added woody encroachment to our plant community structure indicator. And this was lacking in the Saskatchewan and Alberta assessment methods, other than Alberta's TAME. Do you have any comments about that?
Oh, that'd be great to hear that. So I want to learn. I want to know.
Yes.
Yeah. Please email me. We can have separate talk and chat together. I want to learn. Thank you.
Perfect. I'll let May reach out to you directly then about that. We don't have any more questions at the moment, but I'll let everyone take a minute to type it all out there. And And I just want to remind everyone that our webinar is being recorded. So if you missed it, or if you have a friend that you think would really enjoy it, then it'll be up on our YouTube channel later today. And that's youtube.com/user/skpcap. So a listener named Ross is wondering, he says, great presentation. And in concert with Mr. Hayerta's comments, do you think evaluating these systems as a pulsing system where the WPE pulses based on the stressors?
I don't quite understand the question. Can you repeat it?
Do you think, sure, do you think evaluating these systems as a pulsing system where the WPE pulses are based on the stressors?
I think it's quite complicated. The stressors can come from different aspects, right? Yeah, I don't know how to answer this question, honestly.
That's okay.
Yeah.
No problem. The next question is from Graham, and he says, do we have any idea on the pre-contact grazing and fire interval in Saskatchewan? It might provide some insight into how to graze and manage our grasslands to their evolved management. So he's talking about fire by First Nations and grazing by bison. Do you have any thoughts?
Yeah, because fire and basin two major factors. We do have fire in Saskatchewan, long history, right? Many years ago, but to quantify this is difficult. And the basin, we know for basin probably even easier, because if we talk about the protected area, it's monitored clearly, accurately. For ranchers, they have clear understanding how many basins and how many cattle there. But the interaction, we know in the prairie area, in the United States area, so they have the research station to see the influence of combination or separate factors to influence. But I'm not aware any clear understanding before, for certain time before. Because each factor can be affected many factors. For burning, which time of burn, how frequently you burn. For basin, for the grazing, same thing. Continuous, rotational, the grazing intensity, and all these factors.
Yeah.
Sorry, not to answer that. Yeah.
No, it's a hard question.
Yeah. Good question. Very good
yes.
question. Yeah.
Grant is wondering if you can mention again which has greater carbon sequestration, mixed forest or mixed grassland?
Of course, that's also difficult, because I see one study indicate the productivity is higher in mixed forest, right? But for some indicate the grassland actually from the long run it has higher. So to me, with trees, higher photosynthetic activity, the higher biomass probably, but in the long run can be different.
Okay, thank you. And then another listener is wondering if there's any grass community that's resistant to woody encroachment.
That's a good question.
Yeah.
Yeah. I don't have the answer currently, but I know for different grassland communities, the resistance the woody plant encroachment is ability is different. I don't know which one it has a higher ability, which is lower, especially in Saskatchewan. I mentioned that I'm only new to this field for about 2 years. I'm still in the deep learning stage.
Yes. Well, something to add to the list then. It's a good question, something to think about for the future.
Yeah.
And a listener named Aaron is wondering, or he says, I've been noticing Siberian elm establishment in disturbed or degraded lands like roadsides and abandoned farms, as well as Scots pine in recent years during drought. Have you considered increased nitrogen deposition from pollution as a possible driving factor?
Oh, actually nitrogen deposition, it is a factor. So some studies indicate that as well. I cannot list all. So it is a driving factor. Yeah.
Okay. And Troy is wondering if you have any ability to use remote sensing to discriminate or distinguish between sagebrush from other shrubs when you're inventorying cover and detecting change in it.
Sagebrush, because of the color, is different with other shrub. Normally, we see from remote sensing perspective, the ability to differentiate from different aspects. One is the color, the appearance, because sagebrush, the greenish color, silverish color will be easier, or the higher reflectance in the visible portion. And also we distinguish different type of shrub or the grass is based on the photosynthetic activities, the vigor, and different aspects. It is possible. And
Okay.
another thing is the cover percentage. I mentioned the percentage is a major thing. If the percentage is low, it's very difficult with low spatial resolution. If the resolution can reach to sub-meter, the cover for sagebrush can be higher. It'd be much easier. And also
Yes.
we use the phenology, the different time, the shrub or grass, the different phenology can make it easier to distinguish.
Okay. So our next question is, can you distinguish or can you identify different species of shrubs with the satellite imagery? For example, wolf willow versus snowberry. Can you tell the
That
difference between that?
that's a very good question. And sometimes for remote sensing to distinguish species at that level is very difficult. Uh, but when we combine because they have different color, phenologies, structure, we have to consider all this. It's possible, but at this moment, it's still difficult. We have to also consider the phenology. In Xulin's one paper, she tried to separate the two species, wolf and also the berry, the two species. It's very difficult. We use the ground level hyperspectral to focus on the full cover of that shrub without the percentage of shrub in the landscape.
Okay, that is interesting. I imagine it's quite difficult.
It is difficult at a species level. Yeah.
Yes. So a few people are wondering about the rate of encroachment. Do different species of shrubs have different rates of encroachment?
I believe so. I don't have any results for that yet. The overall, the increase rate is in the range of between 0.1 to 2.5, 2.3 ish. If it's normally we see if it's higher than, what's the number? Higher than 1.5%, it counted as a severe situation already. I don't remember the number Xulin did for the, it's a still preliminary result because we used the 2 time of air photo to see the changes, and hopefully based on that 2 time period, we can see what the change occur. Another study for the Danielson and Douglas Provincial Park area, we did also the same thing. But historically, we don't have high spatial resolution imaging. We cannot
Okay.
get the quite a detailed, specific, or the accurate change rate. But in prairie area, the range is quite high now.
Okay.
The
Okay.
increase rate, yeah.
And do you think that grazers may prefer different species of shrubs and then they can influence woody encroachment based on their preferences?
I don't know because I'm not a rancher. I don't know if they can. You can actually normally the woody plant encroachment is not before you realize that it occurred. Most situation is naturally occurred based on the seed availability, based on the climate, the carbon, nitrogen, and so on. So when you realize it's quite late. I'm not sure if ranchers actually manually introduce the shrub into the landscape. I haven't heard about that yet.
No, interesting.
Mhm.
Which shrub species contributes the most to woody encroachment?
In Saskatchewan right now is a berry plant,
Okay.
western berry, and in
Okay.
Cypress Hill with two other species as well, and in Saskatchewan area, the western berry is a major one. That's my understanding. Maybe I don't know clearly about the overall situation.
Yeah. Interesting. And then the last question, because I know we're running out of time here. Shrubs and woody plants can provide living habitat for birds. Will you be interested to research on WPE and bird communities?
That's if you remember the slides, the study they talking about the different pests and the bird. I know, for example, in Grassland National Park, they have certain birds prefer for the shrub, right? Especially
Yeah.
the dead shrub in that area. So if anyone's willing, I'm willing to work together for that because I don't know anything about the bird. I need to work.
Okay.
That's why you see, I work with ecologists, biologists, Eric Lam. We work together on that project. I can provide the aspect from remote sensing perspective, but I need any ecologist person to work with.
Yes, it's that's what your slide says, suggestions and collaborations.
Yes, yes, yeah.
Yeah. Um, and so do you have any considerations for WPE in grasslands or other ecoregions like aspen parkland or the boreal transition?
Yeah, because our I mentioned about the prairie landscape inventory plus project. That project, our mapping going to that ecoregions already, but our shrub encroachment, woody encroachment, we haven't really identified. Actually, Merrick provided me one set is in the transitional boreal transitional area already.
Okay. Interesting. Well, I think that's all the questions that we have. So I just want to thank you again for the awesome presentation. It was really, really informative. And again, for sharing your passion and excitement about this topic with us. So thank you.
Thank you for the opportunity. Yeah.
And to all of our listeners out there, thanks for staying on to the very end. When you leave today's webinar, you'll get a quick 1-minute survey. It'll just take a minute to to fill out, and we use that information to report back to our funders. So we really appreciate it if you don't mind taking that time. So again, I just want to say thank you so much for attending, and please be sure to check out our upcoming webinars. You don't want to miss the one about snowy owls. It's almost full already, so be sure to sign up. So with that, thank you so much and have a great rest of your day, everyone.
Thank you.
Bye.
Bye.